So our last type of inequalities are going to be absolute value inequalities. So we have to remember that when we take the absolute value of something, you are basically taking the positive version of it. So the absolute value of positive 5 is just 5. The absolute value of negative 5 is positive 5. So it's always going to be the positive. So when we get into inequalities, it makes this a little bit trickier. So what we're going to look here is 3x, the absolute value of 3x equals 6. Well, there's actually two answers for this. So if we were to solve this equation, we would do 3x equals 6 divided by 3, and you would get x equals 2. So if you plug that into the absolute value, then you would have 3 times 2, and that would be equal 6. So 3 times 2 is 6, so the absolute value, 6 equals 6. However, we can also do that with it being negative, because remember our example right here, if you have a negative answer, the absolute value is still positive. So 3x equals negative 6, and we would get x equals negative 2. So we have two answers here, because if we make 3 times negative 2 inside the absolute value, then you get the absolute value of negative 6, which we know is going to be 6. So you still get the same answer. So with that, we get a little bit of difficulty when we go to absolute value with inequalities, because now we have different rules too, because we have less than or equal to or greater than and equal to signs. So what I want you to write down, you need to write down that if you have a less than or equal to, you're going to write it like an and question. So that kind of brings us back to yesterday's work where we were doing the compound inequalities. Now, if you have a greater than or equal to symbol, then that's going to be an or. And a way to remember that is if you spell greater with an OR instead of an ER, then you can remember that greater or greater than or equal to goes with or. So if we look at this first step here, so our first problem says the absolute value of n minus 1 is less than 2. So since it's less than or equal to, I'm going to make it an and problem. So when you make it an and problem, what you do is you put the problem in the middle, you put the problem here. So this whole part stayed the same, so we didn't change anything. All we did then was add a less than symbol here, and then you also make it with a negative 2. So whatever the number is, that's what you're going to change it to. So it'll be just the negative of that number. And then from there, it's what we were doing yesterday with the compound inequalities. So we have to solve. So we're going to do plus 1, and you have to do it on each side, all three sides. So negative 2 plus 1 is negative 1. Then ends in the middle by itself, and 2 plus 1 is 3. And then from there, we have to graph that. So we're going to put, remember, read from left to right. So n is greater than negative 1. So n is greater than negative 1, so we're going to put an open circle on negative 1, and greater than goes to the right. And then when we get to 3, we have an open circle, and it says n is less than 3, so we go to the left. So then all of these solutions here will satisfy that equation. Now this next one here, it says n minus 1 is greater than 2. So what happens is, remember, if it's greater than or equal to, you make it an or problem. So you repeat the problem here. So we did n minus 1 is greater than 2, so that part is repeated. And then for your second part of your or, what you're going to do is you're going to repeat the problem, so n minus 1. Then you flip the sign. You flip the sign here, so instead of being greater than, it became less than. And then you are also going to change the positive number here, so the 2 to a negative 2. So there's two things you have to do there. First step, keep it the same. Second step, you have to rewrite it, flip the sign, and flip the sign of the number. So if it was positive, make it negative. Then you're going to just solve these two separately. So you're going to have n is less than negative 1, or n is greater than 3. And then we're going to solve. So n is less than 1, open circle, arrow going to the left. N is greater than 3, open circle and 3, arrow to the right. So we're going to take a look at two more examples because those get a little bit confusing. So we have y minus 2, the absolute value is less than or equal to 1. So less than or equal to means we're going to make it an and problem. So you're going to start by writing y minus 2 is less than or equal to 1. You just rewrite. Then on the other side, you keep the same symbol. So it was a less than or equal to symbol, so you keep that. And then it was a positive 1, so we're going to make it a negative 1. And we're going to solve the problem. So we're going to add 2 onto each side. 2 minus 1 is 1. And then y is by itself in the middle, and 2 plus 1 is 3. So now we're going to graph that. So we're going to put a closed circle on 1. And since it says y is greater than or equal to 1, we're going to go to the right. And we're going to stop at 3 because we have that y is less than or equal to 3. So then this inside part here is my solution. So if you were to plug any of those numbers in there, they should work. So if you plug 1 in, that should work because 1 minus 2 is negative 1, and the absolute value would be 1. Now down here we have 8n, the absolute value is greater than or equal to 24. So greater, so we have to make it an OR problem. So when you do the OR, you copy the problem. 8n is greater than or equal to 24, so nothing changes. For your OR then, that's where you have to change. So you keep your absolute value the same, so 8n. And then you have to flip the symbol, so instead of it being greater than or equal to, we're going to make it less than or equal to. And then instead of it being positive 24, we have to make it a negative 24. And then we're just going to solve. So here we are dividing 8. So you get n is greater than or equal to 3. And again on this side, divide by 8. So then you get n is less than or equal to negative 3. And again, we have to plot our points here. So on negative 3, we are going to have or on positive 3, n is greater than or equal to 3. So we're going to put a closed dot. And then greater than, so it's going to go to the right. And n is less than or equal to negative 3, so you're going to put a closed dot on negative 3 and go to the left.